Recall that a proportion is a statement that two rates are equal. For example, here we're supposed to solve the following proportion, where we have x over 3 equals 4 over 9. So our proportion has the unknown x, and we're supposed to solve for x. What's keeping x from being by itself is that it is divided by 3. So what we need to do is multiply both sides by 3 in order to get x by itself. So we'll have 3 times x over 3 equals 3 times 4 over 9. On the left-hand side, what that's going to do is cancel the 3's, leaving us with x. And on the right-hand side, we'll have 3 times 4 divided by 9. 3 over 9 simplifies to 1/3, and so our final answer will look like 1 times 4, which is 4 over 3. In this example, we're supposed to solve this proportion for x. Here we have x showing up in the denominator, and so we'll use a technique called cross-multiplying. First, we'll look at the numerator of the left-hand side and the denominator of the right-hand side, and we'll multiply those two together. 1 times x is x. And then we're going to look at the denominator of the left-hand side and the numerator of the right-hand side together, and we'll multiply those. X plus 3 times 4, or 4 times x plus 3. Any solution to our original equation will also be a solution to this equation. To solve this equation, we'll distribute on the right-hand side. So we'll have x on the left-hand side is equal to 4x plus 12 on the right. We want to get the x terms together, so we're going to subtract 4x from both sides. On the left, this will leave us with negative 3x, and this will be equal to 12 on the right. Now we'll divide both sides by negative 3. On the left, we'll have x, and on the right, we have a negative number, since we have a positive divided by a negative, and then 12 over 3 is 4. So x equals negative 4 in this case. There's a subtlety here. This is actually just a candidate solution. We said that any solution to our original equation is also a solution to the equation we get from cross-multiplying, but it may not be true that a solution we get after cross-multiplying is also a solution to our original. In fact, we need to go back and double-check that our solution does not give us anything that's undefined in our original. Now, what would be undefined is if our solution makes a denominator 0 in the original equation. Well, here our two denominators are x plus 3 and x. If we plug in negative 4 to x plus 3, we get negative 4 plus 3, which is equal to negative 1. So that's not equal to 0, so that's okay. And if we plug it into x, we just get negative 4. And so that's okay as well. So that tells us that our solution is x equals negative 4 because it does not make any of the denominators 0, so it's a valid solution. Let's check for understanding. Work this one out on your own and then come back and check your answer. Since we have y showing up in the denominator, we'll use cross multiplication. So first, we'll take the numerator of the left-hand side and the denominator of the right-hand side and multiply those together. That's going to give us 3 times y plus 3. And then we're going to take the denominator of the left-hand side and the numerator of the right-hand side. That will give us 4 times y plus 5. Any solution of our original equation will also be a solution of this equation. Let's distribute on both sides. This is going to help us get rid of these parentheses. We'll have 3y plus 9 on the left, and that's going to be equal to 4y plus 4 times 5 is 20. Now let's get all of the y's onto one side, so I'll subtract 3y from both sides. That's going to leave me with 9 on the left-hand side is equal to y plus 20. So now I can subtract 20 from both sides. So I'll have y is equal to 9 minus 20, which is negative 11. Now remember, this is just a candidate solution. I need to go back and double check that this solution does not make any of my denominators 0. Since y plus 5, when I plug in negative 11, is going to give me negative 11 plus 5, which is negative 6, I'm okay because that denominator is not 0.
So then y equals negative 11 is my solution.